Assalamualaikum warahmatullahi ta'ala wabarakatuh and a very good afternoon. Welcome to our 26th session of webinar series Captain of Industry, brought to you by the Faculty of Engineering UTM Johor Bahru. We are initiating university-industry collaboration during Recovery Movement Control Order RMCO to have a platform with our Captain of Industry to share their thoughts on way forward and challenges during post-COVID-19. Now we are streaming live from Facebook Faculty of Engineering UTM. Today, we would like to welcome Dr. Seyed Mohseni, Chief Executive Officer, Samad Aerospace, with his interesting topic today entitled Third Aviation Revolution. Without further ado, I would like to invite Yang Berusaha Professor Dr. Engineer Dr. Muhammad Rafiq Dr. Abdul Kadir, Dean Faculty of Engineering, to introduce our captain today. Over to you, Dr.
Thank you very much, Murni, for chairing the session. Assalamualaikum warahmatullahi wabarakatuh. Hello, welcome everyone. Welcome to our 26th UTM Engineering Captain of Industry. My name is Muhammad Rafiq and I am the Dean of Engineering, University Technology, Malaysia. Today, it is my utmost pleasure to welcome Dr. Seyed Mohseni, Chief Executive Officer of Samad Aerospace. A bit about our presenter today. Dr. Seyed Mohseni is a serial entrepreneur and former CEO of Samad Power, with successful growth and expansion of the company to be the UK first clean tech company for 2 years in 2015 and 2016, with a successful track record within 20 years in technical roles, including Siemens and ExxonMobil. His academic background is aerospace engineering design from Kingston University and MSc in Aerospace Propulsion from Cranfield University, followed by his MBA and doctorate in gas turbine technology, also from Cranfield University. So that is a brief biography of our speaker. Here now is Dr. Seyed Mohseni, Chief Executive Officer of Samad Aerospace on the Third Aviation Revolution. Dr. Seyed Mohseni, over to you.
Thank you, Dr. Muhammad Rafiq. Assalamu alaikum, everybody. It's my pleasure to be with you and talk with you on this exciting subject of Third Aviation Revolution. I'm going to share my screen with you. Okay. Okay, today we're going to talk about the subject of important matter within the Third Aviation Revolution. And the key focus of this talk is going to be around the enabling factors that requires to be looked at so that we can see the Third Aviation Revolution happens in the world. The subject of this talk in particular, apart from the new paradigm change within the aviation industry, is the electric and VTOL aircraft integration into air transport environment. The first aviation revolution happened when the wooden aircraft changed to metal aircraft. What you can see on the top is the famous Douglas DC-2 legendary aircraft that was made all in metal, and KLM started using this aircraft as a passenger aircraft in the aviation industry. Followed by that, the second aviation revolution was when the jet engine was invented by Frank Whittle and some other scientists also in Germany in similar times towards the end of World War II. The second aviation revolution enabled a lot of airlines to make use of the jet engine or turbofan engines were installed on the passenger aircraft, and still up to this day, almost all of the aircraft, the passenger aircraft that we are using in the aviation industry, they run on gas turbine, and it's one of the key prime movers within the aviation industry. But the third aviation revolution is emerging, and it has already started to happen now with hybrid, electric, and also VTOL aircraft. Some of the enabling technologies that has allowed these products to be developed and also moving into certification and manufacturing, then later on coming to the market. So there are three key technologies that has been they have been used to allow these products to be developed. One is electric motors using permanent magnet technologies, and are significantly higher power to weight ratio. Also battery technologies with significant investment of major companies and also governments that have made into the development of the new batteries. And third are the IT and connected autonomous technologies that they are allowing more advanced flight control systems and more advanced methodologies for flying an aircraft at the same time that this is happening in the automotive industry as well. Today, I want to bring your focus on some of the underlying factors that needs to be looked at if we want to see this industry flourishing. And these might not, in the first instance, look to be particularly on the product, but it's more on the environment of the future of flight. Each of these topics that I'm going to talk to you about, there are potential collaboration topics that industry and universities, they could come together and work on this. Currently, this is part of our focus to be able to allow this new product coming to market at ease, and the commercialization becomes simpler. So the key topics that I'm going to talk about is that what is the future looking of the cities with advanced transport systems? Who are the people who are going to use this type of air transport system? Why they are using it? What is the size of the market? Because at the end of the day, if the market is not attractive, then the industry would not flourish. And how can we define the market? What are the infrastructures required in terms of the vertiports and in terms of the charging system required to be provided for this type of aircraft? And for electrification of the aircraft, what are the support systems required to support the use of this type of aircraft? Obviously, as we have more numbers of these aircraft coming to the market, the air traffic management system have to match and also has to have the capacity to be able to allow these aircraft to fly. How can we integrate this new type of transport system with an existing transport infrastructure that exists in different countries at the moment? And at the end of the day, what is the passenger experience? How can we make sure that the end user would receive what we want them to receive? So, as majority of you probably know, the aviation industry is growing very fast, and the market reports shows that by 2050 there would be 6 times more people flying around the world. And so there is a demand for higher level of connectivity and better energy efficiency in the transport system, and even moving towards zero emission environments. In this particular topic, we are focusing on a pragmatic solution. What is the early adaptation of an efficient sub-regional advanced vertical takeoff and landing aircraft? And what is the enabling transition into the future? Because we have an existing infrastructure, an existing factors that has to work all of them together to allow the current aircraft to work. We want to bring new type of aircraft to the market, and how this new type of aircraft would come into the aviation environment. If we take one segment of this particular market, which is intercity transport, and this is in particular is the focus of Samad Aerospace with its hybrid electric VTOL aircraft. If you think about the short-haul flights, there are hundreds of flights in the countries. I'm sure in Malaysia is the same, in UK and different European countries. And there are a lot of flights that the duration of the flight is less than an hour, but the total time spent for that journey, for that 1 hour flight, is more than 3 hours. And the reason is that the time that we spend going to the airport and coming out of the airport. The other means is there are certain routes that are very difficult, and there is no existing air transport that could be used by people. As an example, Cardiff to Manchester in UK. Typically, it takes 3.5 hours of driving by car. There is no existing flight route to the 188 miles of journey. The same journey can be done using e-Starling aircraft for a city-to-city transport with about half an hour of flight to 45 minutes. So significant time saving can be achieved, and therefore increased productivity for premium level travelers, which on its own can benefit the environment in large. So the people who would be using this type of service, these are the topics that the universities could get involved and help Samad Aerospace and also other companies to understand the details of the market, the underlying reasons behind the reason that people would use this type of service. So in this topic, we would be interested to look into demographics of people who would be using intercity transports. We are interested to know what is the financial strength of these individuals or family members or families that they would be using intercity VTOL air transport. What are the reasons that they would use this service for? How do they prefer to use this service? What are the pricing that they're happy to pay for this type of service? As an example, currently the first class train ticket from London to Manchester costs about £250. Now, if a company comes and offer an air transport service with time saving of minimum 50% and ask for £500 of the cost, our consumers are happy to pay this price to receive that service. This needs to be researched for. The other topic that people are very important in here is the people who are not using this service, and really meaning community acceptance. What is the level of acceptance of community for this type of service? What is the noise level that people, beyond that level, people would be unhappy, and therefore it would be difficult to use this type of aircraft in the urban area? What should be the design of the vertiports that we would cover in a minute? The potential market for this type of intercity air transport, there are two types of market for Samad Aerospace and any other companies who are looking into this area is available at the moment. The existing market are existing executive helicopter and business aviation aircrafts. And these are pretty much known markets that, there are market reports about them. The market size can be defined. Also, for our new two-seater luxury e-Starling, which you probably would hear about it during the next few weeks when we make the announcement of the aircraft. It's like a flying Lamborghini in a way. The particular market is ultra high net worth individuals, that there are about 180,000 of them throughout the world. The people in particular who will be using e-Starling for intercity air transport, there are about 18 million people worldwide. That's the initial market. But the emerging market needs to be looked at, and this is again another topic that we would be interested to see how universities and other companies could get involved to provide valuable data for us. The particular data that we would be interested is to find out where the VTOL aircraft could operate currently in the countries using existing VTOL vehicles like helicopters. What are the sub-regional airline opportunities that could be looked at in here for a 5-seater aircraft? And what is the frequency of these flights? How often we can rely on the air routes? In particular, the suggested method is to look into traditional historical analysis, understanding the routes and frequency of these air routes. How can we financially make sense of using the existing routes? And then the next step, we would be interested to look into the data that is publicly available through CAA of different countries, so that we can find out the profile of the passengers, the type of profiles of the passengers, and also understanding the originations of the journeys before they come to the airport. Then in a third level, we go into more details of getting some better detailed data through mobile phone to understand the purpose of the transports, the demographics of the customers, and also do some catchment analysis as well. So the mobile data, that in this case, there's a company that is helping us on this case, is using mobility analytics engine to turn the raw data into real insight of the reasons and the qualities of the journeys, the type of the consumers and the passengers who would be traveling in these routes. Also, we would be interested to look into the distances of the different destinations that have been chosen by people. Vertiports are very, very important, and the economics of vertiports are also important, because if we want to have a thriving electric VTOL air transport system, we need to have the correct infrastructure in place. And the economics of vertiports are important because there would be companies who would be running a vertiport similar to the companies who are running the airports. And therefore, the study on how many flights would make sense for a typical size of airport vertiport, and where is the place that we could put these vertiports. We have done some conceptual work with Pascal and Watson, looking into different designs of vertiports. How can it be integrated with existing systems, and how practical would be from the planning permission, and what are the type of vertiports that we could have based on the city or the town that we are installing the vertiports for. Also, where the energy is coming from, which is a key factor. So we are not looking into just how the aircraft would be flying and would be charged, but how the energy of these vertiports would be supplied, and how can we use the existing renewable sources of energy to provide the required power for these vertiports. So coming to the aircraft itself, in particular, apart from the development, a typical development of an aircraft, which I'm sure majority of the good universities in their aerospace and aircraft design departments, they know how to do that. But we are more interested to see how the design would affect the environment, and how can we choose a design that would match with the expectation of the communities. So, for example, what is the downwash effect? What is the wake turbulence of this type of VTOL aircraft in relation to existing buildings and design of the vertiports? So the technical considerations are also very important. The downwash effect on the ground, and where is the level that in a way it upsets people, and what we need to avoid. What is the threshold for loudness, and also the separation for wing-borne aircraft to VTOL aircraft. So an aircraft is VTOL as long as the lifting elements are keeping the aircraft in the air. But the process of transitioning from the VTOL to CTOL when the aircraft is wing-borne, in that process, what is the effect of the noise and the aerodynamics and the emissions on the environment? This is something that we would be particularly interested. In Samad Aerospace, we are following the Spiral method of development, a roadmap to e-Starling. So we have started building the prototypes in 2018. Once we confirm the concept that we're going to look for, we have built various prototypes for obviously different purposes in the path of our development. We might have some of these prototypes be spin-off products to be taken to civil UAV market as well. So the spiral method of development is what you see on the left. Is we break down the complex systems into smaller packages of technology blocks. We build smaller, simpler prototypes. We test them. Once we confirm, we add the complexity and we turn around. So where we are currently is the red circle that you see, S5U, and the aircraft that you see on the right. This is towards the end stages of the half-scale prototype of e-Starling. This would be unmanned, and it's not publicly available yet. But I mean, from now, this is the first event that I'm announcing the last stages of the build for the S5U, the half-scale prototype of e-Starling. It's all composite airframe with all-electric propulsion. Obviously, for the purpose of the demonstration and also the test, we don't need to have long range, and therefore all-electric is possible for this aircraft. The other important factors for the future of the Third Aviation Revolution is the charging infrastructure, because it's not about charging of the aircraft, it's about availability of the power at the point that is required. So if you take a typical electric aircraft that has a battery pack of 100 kilowatt hour, the 100 kilowatt hour battery would require a very fast charging, because if you put a typical 50 kilowatt charging for that, it would take 2 hours to charge that battery. But if a VTOL aircraft is coming to a vertiport, for the vertiport economics to make sense, the aircraft needs to take off within 15 minutes. So we have about probably 10 minutes for charging. That means we need to have a 600 kilowatt charger to charge that 100 kilowatt battery in 10 minutes. So to give you an idea, a 600 kilowatt charging facility is equivalent to 1,200 homes power demand. Typical power demand of houses are about 500 watts on average. So where the power is going to come from, because if a particular road has been designed to have a 2 megawatt power cable, if we suddenly demand 3 megawatts from it, how the power is going to be transferred, where it's going to be produced, and if it's going to be produced via coal or another fossil fuel, what is the point of having electric aircraft when the source of electricity is through fossil fuel? So the charging subject is looking into how the aircraft would be charged economically, but at the same time, how this charging would benefit the environment in large. The matter of air transport management is very, very important, because there are existing helicopter routes that we would be using for e-Starling at the moment, and also any other intercity aircraft would be using existing helicopter routes, but these routes are limited. And at the same time, these aircraft would not stay helicopter. After a few minutes, they become an aircraft in the class of general aviation type aircraft. So that's a different air transport, different level of air transport management system. And for some of the other aircraft, similar to our Starling Jet, where it needs to go into international routes, then it's another level that needs to be overlaid. So now we have an aircraft that would fly in the beginning similar to helicopter, then it goes to general aviation environment, then it goes to the higher altitude level for international transports. So the subject of management of these is of importance, and as it's been suggested in the CONOPS report of NASA and FAA, most probably in the beginning these aircraft would be using existing transport systems. Apart from that, also we want to maximize the utilization of existing airfields. There are hundreds of airfields throughout the UK and probably thousands throughout Europe and the world that they are underutilized. So in the beginning, we would be interested to look into optimization of the routes through the existing airfields and in connection with the existing air transport systems. So let me just check my timing. Okay, yeah, that's good. So because as I said earlier, this aircraft, e-Starling, is mixing the helicopter routes with also having the international routes of flight as well. And this needs to be looked at in that environment. The other subject that would be interested for us, and also, as I said, is these are the factors to enable the third aviation revolution to flourish. We must look into integration of this type of air transport method with the existing transport systems. And if it's not fitting the existing transport systems, then it's not going to flourish, it's not going to expand in its use. Again, one of our partners, Pascal and Watson, they have been looking at how the vertiports could be integrated with the current systems. For example, looking into design of vertiport above the train stations as the hub of transport, or even looking at a more maybe riskier approach. How could we have vertiport above petrol stations, even for a single use of VTOL aircraft, and optimizing the use of the aircraft with the frequency of the passengers traveling in these hubs. And finally, the passenger experience. How can we make sure in today's environment that people are demanding, rightly, ease of use of services? How can we make sure that this new service is very easy and seamless experience for people? So we have been looking at integrating of the intercity transport with existing ride-hailing services, where an individual would decide to go from A to B. They put their destination in their existing Uber or Grab or any other ride-hailing services and in the final destination, and then Grab would be working with an existing operator who would make use of the VTOL service. So the car would come, pick up the passenger, take them to the vertiports. In the vertiport, the aircraft is ready to take them to the next vertiport near the destination. And just as before the aircraft is going to arrive, the taxi or the Uber taxi or Grab car would be ready to take the passenger to their final destination. And how can we make sure that this would give them a very comfortable experience to allow increased number of people joining this service? So in summary, enabling the third aviation revolution requires strategic thinking into four main pillars of aircraft systems and the technology, which is probably the core part of it. Then looking into certification of these aircraft, these type of aircraft, mainly through EASA and FAA and probably through civil aviation authorities of other major industries and economies. The social acceptance and understanding what would benefit the society and community so that the society will welcome this change in the transport system, and also the infrastructure required to allow larger number of aircraft coming to this use. So all of these have to come together to allow the third aviation revolution becomes a reality when it obviously has to satisfy the requirements of these four pillars above. Thanks very much for your attention. Any question, I would be happy to discuss it with you. Hello? Hello?
Seyed, for your interesting presentation about future aerospace, aviation, what we call it, industry, and also a kind of transportation. Third revolution, right? Yeah. So yeah, it just remind me about the wooden edges of the aircraft convert to metal. Is it the first revolutions, and second is the jet engine, and now coming in the hybrid electric aeroplane. So maybe some of our viewer would like to know that some of terms that we use, a VTOL, actually representing the vertical takeoff and landing aircraft, yeah, and we have the vertical port, yeah. Maybe some of the our viewer, Dr. Seyed, not familiar with the aerospace terms, things like that. So probably I just brief a little bit about the VTOL and conventional takeoff and landing aircraft, yeah. Yeah, Dr. Seyed, while we're waiting for a question from audience, I believe that you have something to show on the video, things like that. Yeah.
Yes, yeah. So we also these are the tests of in the roadmap that I showed you. The tests that we have.
Yeah, it would be nice if we can see some of the videos of testing. Or yeah.
Of course. Then let me just go through. So this is the I will share with you. This is the test of the S1.
S1, yeah.
And that was done about 1.5 years ago, and then we have some S1P, which is more recent.
Yeah. Thank you. Yeah, Dr. Side. Yeah.
Yeah,
Dr. Side, can we take one question from
sure.
Sharifa Kamila Said Yusuf? She has a question. How is the service going to be regulated, in particular when international air traffic is involved? So what about the safety issues of the services? Dr. Said?
Yeah, absolutely. So when it comes to the international transport, currently the service that is available is for business jets. So if we have an aircraft that is going to go through international routes, it has to be using the existing routes that business jets are currently using, and obviously has to reach that level of altitude to be able to fly that. General aviation for some of the regional flights is also possible as well. So we are not trying to create totally new air transport routes. We would be utilizing the existing ones, and obviously as the number increases, we would look into how we can increase the capacity of existing infrastructure, and then there would be a point of moving towards the 4D air transport control systems, where significantly more number of aircraft could fly in the environment.
Yeah. So meaning to say that we have to deal some of the regulatory body in order to, secure the security and the safety of the flight and the community, right?
Yeah, I mean this is when it comes to, let's say, because this aircraft in the beginning, the first stages of its flight is flying similar to helicopter. So the requirements of anything to do with the safety and security should not be less than helicopters that are currently in use. And then once it moves to wing-borne flight, becomes a general aviation type aircraft. So if you have, for example, a PC-12 that is flying, what is the requirement for the security and safety of a PC-12? This aircraft also needs to qualify for that. And then if you want the international flight, it's similar. So we're not expecting anything above or below of existing safety and regulatory requirements.
Yeah. Okay, thank you. Yeah. Dr. Said, can we take second questions?
Sure.
From Ainulutfi Abdul Latif. Given the current COVID-19 pandemic, how could it affect the development of the such concepts and its implementation? This is especially given that normal air travel is severely now, and airlines are going bust. So, what is your opinion? Your comment
Very,
on
very
this?
good point. We actually see this to be a great opportunity because the e-Starling and Starling Jet and type of aircraft that we are developing, these are mainly for personal use or for the use of companies, and therefore that worries and concern element of large number of people coming together in one place like airports, this would be non-existing for this. Vertiports are certainly less crowded than vertiports, and actually it enables the premium level travelers who, and also some of people who have very important journeys to make. They can do that at a safer environment, and therefore we see this to be a growth opportunity for this sector of aviation.
Yeah, thank you. Yeah, Dr. Said, I was informed that there are so many, a few versions of your VTOL aircraft. So, and one of the version is unmanned VTOL, right? So
True.
can you elaborate more about the unmanned development of your VTOL?
Yes. So the pictures that I showed you, that was the unmanned half-scale VTOL aircraft. So this would be for various civil UAV applications. The key applications for the smaller aircraft. The smaller aircraft we have. I'll show you a video of that now. That we have developed a flight control system with autopilot, that we can define the destination for the aircraft, and the aircraft would go. We can define the mission, that what it needs to do during the flight. For this would be for border controls, for forestry observations, for climate control. It would be for disaster recoveries, especially in the first assessment stages that currently helicopters are being used. And helicopters obviously are very, very expensive, costing about $3,000 per hour. This aircraft would cost about $150 per hour. So I'll show you a test of this. It's a simple aerodynamics, but our focus has been on the flight control system because it's very similar to the e-Starling in future. So let me show you the flight test for that as well.
SIP stands for what, Dr. Seyed?
S1P is,
S1P,
I mean, S for Starling, 1P is because this is a 10% prototype. It will have its commercial name in future, and the final product would look slightly different, but the configuration is is pretty much the same. The purpose of this has to be to provide the data that we require for flight control system, at the same time to be a very cost-effective aircraft to be used for our type of customers. So we are not trying to increase the luxury element of it.
Yep.
So it's going through the transition now. Now it becomes an aircraft now. Once it becomes an aircraft, then we don't need the other rotors, the VTOL rotors, the lifting ones. They would stop working.
Landing, yeah.
So all of this flight, this was as an example, all of it was done in an autopilot mode, and we did very similar one with that S2P. And we have done the CTOL test, which I'll show you the video in a moment. And that was also on the autopilot that was developed by Samad Aerospace team. This is a mix of 3 flights together, so it shows 3 takeoff, 3 maneuvers, and 3 landing.
This is the camera installed on the aircraft itself, right?
Yes, this one, the camera is at the tail of the aircraft.
Yeah, it's climbing now. Yeah. Where is it? It's just the site, this
So
testing area.
we have different suppliers that they would
Mm.
support us, and
Mm.
obviously for flight permissions, the Asian countries are in a way easier, especially in Middle East. We have
Yeah.
found it to be
Oh,
easier for us to use
yeah.
the remote airport,
Area. Yeah, airport. Yeah.
whereas in
Mm.
UK and Europe, the permits to fly
I could
are
understand that. Yeah. Mm. So it is somewhere in Middle East, right?
yeah. So
Yeah.
these
Thank you. Yeah.
these flights, there were 3 flights on this, all of it again
Mm.
been done on sort of using
Yeah.
the autopilot.
Yes.
We are
Yes.
almost to the end of the paint of the S5U,
Progress. Yeah.
and hopefully you will hear during the next few weeks the
Mm.
announcement on the flight of the half scale prototype, which is a a
Yeah.
very significant milestone for us. The data that we receive for the half scale prototype, it
Mm.
pretty much gives us a good aerodynamic data
That's good.
on the e-Starling as well.
We have one more question, Dr. Said, from Muhammad Anwar Hussein. So, what are the important parameters to be considered while manufacturing aircraft in the context of passenger safety?
I mean, when it comes to the passenger aircraft, there are large number of aspects
Element,
that we
parameter,
need
aspect, yeah.
to look at, and one of the significant achievements of the manufacturers during the last, I would say, 40 years is a phenomenal level of safety that has been achieved
Yeah.
for the passenger aircraft. And whilst this is very good, and the has been an evolutionary process to increase the safety level, it has increased the bar of standard for the new developments of passenger aircraft, and therefore for us to, as a new startup company similar to other startup companies in US and Germany, we need to work a lot to be able to reach the standard requirements for the aircraft.
Yep.
And obviously in here there are key elements. One is the fail-safe strategy that needs to be looked into, design and build of almost every component and subsystem. That's one thing. The other one is the redundancy that needs to be in place. And there are a lot of factors that needs to be taken into account when we want to manufacture a passenger aircraft from safety point of view. But the points that I can mention from the strategic point of view is fail-safe strategy and redundancy in place. And these are
Yeah.
the two key driving factors for safety of the passenger aircraft.
Yep. Yeah. Thank you so much, Dr. Said. There's one more question coming up. Yeah.
Sure.
Can we entertain that? Yeah. From Haris Azwan. At what altitude would this type of aircraft fly? Same as
Very
turbine engine or lower?
yeah,
Yeah,
good
good
point.
question.
So
Good question. Yeah.
we for us for the e-Starling, e-Starling would be flying maximum at 25,000 feet. The limitations that we have is not on the electric motors or turbine engine. Certainly could go higher than that, but for our design is the pressurization of the cabin. So and especially for the
That's right.
innovative
Passenger.
concept similar to e-Starling. That is not a tube cabin. Is a very complex cabin shape, and pressurization of it increases the weight. But I'm taking into account that this aircraft would be replacing existing helicopters, and generally, helicopters would not go beyond 8,000 feet. So we expect the e-Starling to be used below 10,000 feet. But Starling Jet would be designed to fly up to 25,000 feet.
Yep. Thank you for that answer, Dr. Seyed. Yeah, Dr. Seyed, it's our great pleasure to have you in our Captain of Industry today, despite your busy schedule. And then it's happy for me as well because seeing you some time ago, then today we meet again. So maybe Dean would like to say something before closing.
Thank you so much, actually, Prof. Suhaimi, for chairing the session. And to our Captain of Industry, Dr. Seyed Mohseni, thank you so very much for accepting our invitation to give a talk at our Captain of Industry webinar series. You got a lot of interesting slides over there and videos as well. I guess you know already that we have this low wind speed tunnel, the one and only in this region. And Prof. Suhaimi was one of the team members that make it happen. So I guess the collaboration, Prof. Suhaimi, make sure that we can continue our collaboration with Samad Aerospace. And then, I was thinking that, if that kind of personal jet can fit into my budget, I might buy one. But see how it goes.
Very good.
To be honest with you, I love the design. The design is just impeccable. It's my kind of personal jet, if you like. It is certainly interesting.
Yeah, very good point. Actually, I mean, we also have it was actually the design, the concept that we announced in Malaysia in Langkawi Air Show. I think it was last year, where this is for the pure urban mobility, and that is a sort of more cost-effective version that even people could purchase that in future. However, we would the next version of our VTOL aircraft, e-Starling, you probably will see the announcement during next month or so. That is for people like yourself who would be interested to fly their own aircraft. And I know that Malaysia is very interested to get involved in this area. I had about 5 meetings last year with Dr. Martin Muhammad about this an opportunity that exists in Malaysia and how Malaysia could get involved to lead the ASEAN region. And we still hope that those talks would move forward to some practical steps to be taken, and hopefully once the COVID is out of the way, we would be traveling to Malaysia more to set this up.
Looking forward to meeting you in person, Dr. Seyed Mohseni. All right,
Very
okay.
good.
Thank you again, Dr. Seyed Mohseni, for accepting our invitation. And then to all our viewers worldwide, thank you for watching our Captain of Industry webinar series. Until next time, bye for now. Bye-bye.
Thanks so much.
Bye.
Thank you. Bye-bye. Thank you.